Hey you, it's me. Let's talk about sliding windows. Sliding window? Sliding windows. What the heck is a sliding window? Sliding window is a technique used to solve algorithmic problems where we can traverse through an array from start to end one time. The sliding window technique works by creating a start pointer and an end pointer. Then you process everything from start to end and shift to the right after you're done processing. The problem statement that you're given may tell you how big the window needs to be or what exactly you're looking for in terms of your process. That could be something like non-repeated characters or the biggest sum. So for an example, let's say that we have an array with the elements 1, 12, -5, -6, 50, and 3. We're told to make a window size 4 and find the subarray that has the largest average. So what we need to do is find the sum of every window and then return the largest sum divided by 4, since that's the size of our window. So the array that I've given us, our first window, size 4, will be 1, 12, -5, and -6. The sum for this window is 2, and 2 divided by 4 is 0.5. So we'll keep a note of that. And now we're going to slide our end and our start pointers one spot to the right. This gives us an array 12, -5, -6, and 50. The total of this subarray is 51, and 51 divided by 4 is 12.75. After we process this subarray, we now move everything one spot to the right again. So our last subarray of this array is -5, -6, 50, and 3. That gives us a total of 42. We divide that by 4, and that's going to be equal to 10.5. So we know that our middle subarray of 12, -5, -6, and 50 is going to be the subarray with the largest average. So now that we know just in theory how a sliding window technique works, we can put it into practice and we can start solving some problems. I'm going to solve 2 problems from LeetCode today, and they're both easy. These have the benefit of having the window size predefined, which really takes a lot of the work out of a sliding window problem. But remember, a sliding window problem is just going to come down to a couple things: a start pointer, an end pointer, iterating through an entire array or string, you process your window, and then you slide your window. So now we can see it in action. You can find this problem on LeetCode. Number 643, maximum average subarray 1. You are given an integer array nums consisting of n elements and an integer k. Find a contiguous subarray whose length is equal to k that has the maximum average value and return this value. Any answer with a calculation error less than 10 to the -5 will be accepted. We can see here the array that we were talking about earlier: 1, 12, -5, -6, 50, and 3, with k being 4. So we're going to try to find the maximum average of a subarray that is length 4. And here we're given another example: a single element array consisting of just the number 5, and k equals 1. So the average for that is 5. Let's begin to solve this. The first step for solving any sliding window problem is you're going to want to create your start pointer. We initialize this start variable to 0. The reason why we always start it as 0 is because in most languages, an array is indexed at 0, meaning the first element of the array will be at index 0. We also need to create 2 variables to hold our sums. Sum will hold the value of our current window, And max sum will hold the value of the largest sum from all the windows that we have come across so far. Now we're going to start iterating through our array, and we will iterate with our end variable. Inside of our for loop, the first thing that we want to do is process our window. In this case, it means updating our sum. So we add the value of the element at end to our sum. After we do our process step, we need to do our slide step. This is a conditional statement. We want to check to make sure that the window has now reached the maximum length that we are allowing it to be. So here we do if end minus start plus 1 is greater than k. This could also be changed to if end minus start is equal to k. This is just saying that our window is now the exact size that we want it to be. So it's time to shift everything one step to the right. Our first step is to remove the value of the element at index start from our sum. Since we're moving our window one step to the right, what used to be our start is no longer relevant to our next window. Now we update our maximum sum. This will make sure that if the current sum is larger than any sum that we've had before, that will be our new maximum sum. If not, the maximum sum won't change. After we update our max sum, we can move our start pointer one element to the right. Because our if statement is inside of our for loop, this conditional will be checked at every iteration through the array. So outside of the if statement and outside of the for loop, we're going to return max sum divided by k, which will give us the greatest average out of all the windows that we found inside of this given array. And now let's look at one more problem. This is going to be really similar to the problem that we just went through. However, it's going to use something called a frequency counter. A frequency counter is just what it sounds like. You're going to use it to count how often something appears in an array or in a string. In this case, we're going to use it to count characters. Problem number 1876. Substrings of size 3 with distinct characters. A substring is good if there are no repeated characters. Given a string S, return the number of good substrings of length 3 in S. Note that if there are multiple occurrences of the same substrings, every occurrence should be counted. A substring is a contiguous sequence of characters in a string. We have two examples that we can look at. Our first input for a string is X, Y, Z, Z, A, Z. And our second example is AA, BA, BC, ABC. First things first, let's create our starting variable. We initialize it to 0 just like we did before. In this case, we also need to keep track of how many times we come across a quote-unquote good substring. So let's create a variable called goodCount and initialize that to 0. We're going to increment this by 1 every time we come across a substring that meets our criteria. And let's create our frequency counter. We'll call it letter counts, and it's just an empty dictionary. We're going to iterate through our string using the variable end. Our process step is going to check if the character at end inside the string is already existing inside of our letter count. If it isn't, we're going to create a key of that character and initialize it to 0. Outside of that if statement, we're going to increment our key of the current element by 1. That means that whatever letter we just came across, we're going to find the entry of that in our letter count. And if it's at 0 because we haven't come across it before, it will now be 1. But if it's a letter that we've already come across, then the value will be greater than 0. We're going to add 1 to that value. Now it's time to slide our window to the right. While end minus start is greater than or equal to 2, we can take our first window, for example. End would be index 2, and start is index 0. 2 minus 0 is equal to 2. That would trigger this while statement. Inside of this while statement, we're going to check our frequency counter. If all the values inside of our letter count are equal to 1, meaning nothing is greater than or less than 1, then we know that we have a good substring because all of the letters have only appeared one time in this substring. We can increment our good count by 1. Outside of this if statement, we're going to find the key in our letter count that is equal to the letter at index start. We're going to remove 1 from its value. After we do that, we need to do a check. Did that just decrease the value to 0? If so, we can just delete that entry from our letter count. After we've taken care of our letter count, we can now move our start index 1 position to the right. Outside of this while loop and outside of the for loop, we just need to return our good count. I hope going through those 2 problems was helpful. A sliding window problem can definitely get more difficult, especially when the size of the window isn't predefined in the problem statement like we had here. I'm looking forward to in the future going over more difficult problems and different patterns and techniques, like breadth first search, depth first search, cyclic sort, merge intervals, fast and slow pointers. There's a lot to go over. So from me to you, have a great day.